Hello everyone, welcome back to another session of construction planning. Students, in the previous session of construction planning, we have started seeing a numerical based on CPM method. Let us see another question. So here is the second question, that the data for the network is given in the table. Prepare the network diagram and with the estimated duration and find the total duration, critical path, and prepare the table of flows. See, I am not writing in the question. There's three questions that has been fixed, that we need to find three questions: total duration, critical path, and table of flows. But here, as you can see in the question, direct network is not given. Students, in this sum, direct network is not given. Here we need to prepare the table, and to prepare we need to prepare the network. We need to prepare the network, and to prepare the network, table is given to us. So there are activity A, B, C, D up to L having event number. Directly circle numbers are given. Draw the network, type 3 sums: 1, 2, 1, 3, 1, 4, 2, 5, 2, 7, 3, 4, 4, 5, 5, 6, 5, 7. So these all the event number are given and the activity durations are given. So the first step is, if the network directly given, then we can proceed for forward backward. But network is not given, so first we need to draw the networks. So let us start with, and to start with, I will be starting with 1, 2, 1, 3, 1, 4. So let us draw that. Alright, so here is 1, 2, 1, 3 and 1, 4. Now let us see the activities which are starting from event number 2. So come back to the question. So alright, in the question, as you can see, there are next activity 2, 5, 2, 7. Now let us represent that. Alright, so as you can see, 2, 5, 2, 7. Now let us come back to the question again and see what are the next activities. So the next activity from event number 3 is 3, 4, 3, 6. 3, 4, 3, 6. So let us draw that. So I've connected 3, 4 and 3, 6. 3, 4, 3, 6. Now let us see what are the activity from event number 4 and 5. So from event number 4, there is only one activity, 4, 5. So let us draw that. So I've connected 4 to 5. Now let us see the question again. The next is 5, 6, 5, 7. Let us draw that. So here is my 5, 6, 5, 6, 5, 7. Now there are last two activities, 6, 7, 7, 8. Let us complete that. So here are 6, 7, 7, 8. So that is my complete network. Now in this network, we need to name the activity and we need to have the duration. We need to name the activity and we need to have the duration. So from table, the activity name and duration was given. For example, for A it was 8, for B it was 7, for C again it was 8. So let us represent that into the network. Alright, so here is the entire network represented with activity name and duration. For A 6, for B 7, for C 8, for D again 7. So this is how entire I have represented activity name above the arrow and duration below the arrow. Now we have got the entire network with activity name and the duration. So what we can do next? So now we can proceed with forward path analysis, and to perform the forward path analysis, we need to start from point 0. Let us see. So to perform forward path analysis, we are starting from we have started from point 0. Now I want to go from 1 to 2. So from 1 to 2, there is only one activity, A, having duration 6. So 0 plus 6, 6. So we have reached up to point 2. Now let us talk about point number 3. So 0 plus 7. 0 plus 7. 1, 2, 3. There is only one way. 0 plus 7, 7. Now if we talk about point number 4, there are two ways. 1 to 4, 3 to 4. So if I go from 1 to 4, 0 plus 8, 8. But if I go from 3 to 4, 7 plus 4, 11. So I have two options, 1 to 3. If I go from, pardon me, if I go from 1 to 4, 0 plus 8, 8. If I go from 7 plus 4, 11. So we have to consider maximum value. So I'll take 11. Now point number 5, event number 5. To reach 5, again there are two options, 2 to 5, 3 to 5. So if I go from 2 to 5, 6 plus 7, 13. 6 plus 7, 13. If I go from 3 to 5, 11 plus 9, 20. 11 plus 9, 20. So 13 and 20. What is the maximum? 20. So I'll consider 20. Now for point 6, again there are two options, 3 to 6, 5 to 6. So if I go from 3 to 6, 7 plus 4, 11. I'll get 7 plus 4, 11. And if I go from 5 to 6, 20 plus 5, 25. 20 plus 5, 25. So which is the maximum? 25 or 11? 7 plus 4. So 20. Maximum 20. So that is up to event number 6. Now coming to event number 7. To reach event number 7, there are three options. 2 to 7, 5 to 7, 6 to 7. So if I go from 2 to 7, I'll get 6 plus 8, 14. If I go from 5 to 7, 20 plus 6, 26. And if I go from 6 to 7, 25 plus 6, 31. So 14, 26, 31. Maximum is 31. And the last is L, 7 to 8 L, 31 plus 9, 40. 31 plus 9, 40. So that is how the final point will be point 40. So we have reached the final point of our forward path analysis. Now we are coming back, backward path analysis from event number 9 to 1. So again we'll start from point 40. So above there was 40. I'll take the same value as below, 40. So now 9 to 8, 40 minus 9, 31. 40 minus 9, 31. Now 7 to 6. So from 6 there was only one arrow. So reverse can be only possible one. 31 minus 6, 25. So 6 is up to 6, that is clear. 31 minus 5, 26. Pardon me, 25. Now point 5, event 5. So from event 5 there are two arrows coming out, one downward and one that way. So there will be two paths possible, 7 to 5, 6 to 5. So if I go 7 to 5, 31 minus 6, 31 minus 6, so 25, and 25 minus 5, 20. So there are two possibilities, 31 minus 6, 25, 25 minus 5, 20. So while going reverse, while doing backward path, we need to consider minimum value. So that is 20. So that is 20. Now let us come event number 5 up to 5, that is done. Now come back to 4. So again for event number 4, only one arrow is coming out. So 20 minus 9, 11, 20 minus 9, 11. Now event number 3. So for event number 3, there are two arrows coming out, 3 to 6 and 3 to 4. So there are two ways possible, 6 to 3, 4 to 3. So if I go from 6 to 3, I'll get 25 minus 4, 21. But if I go from 4 to 3, 11 minus 7, 4. So 21 and 4, which is the minimum? 7. So event number 3 will time will be 7. Now let us talk about event number 2. So for event number 2, there are two ways possible, 5 to 2, 7 to 2. So if I go from 5 to 2, I'll get 20 minus 7, 13. And if I go from 7 to 2, that is 31 minus 8, that is 23. So 13, 23. So I'll get minimum 13. Now talk about event number 1. Event number 1 has 3 arrows. So reverse path, 2 to 1, 3 to 1 or 4 to 1. So if I go 2 to 1, 13 minus 6, 7. If I go from 3 to 1, 7 minus 7, 0. And if I go from 4 to 1, 11 minus 8, 3. So 6, 0 and 3. 6, 0 and 3. Minimum is 0. So we got our 0 back. So that is my forward path and backward path analysis. And by performing forward path and backward path, I will get the total duration of the project. Total duration of the project. Let us see what is that. So the total duration of the project is 40 days. Total duration of the project is 40 days. So our answer number 1 is completed. Now we'll check for the answer number 2, that is critical path. And to find the critical path, first we need to prepare the table. So let us prepare the table. So here is the table having activity name, duration, EST, EFT, LST, LFT, total float, free float, interfering float, independent float, and the last column is of remarks. Activity and durations that are taken from the question itself. Alright, that was given in the question, so I have written down activity and the duration. Now the first is EST. So let us come back to the network. So EST, as you can see in the network, I'm repeating this. EST is the ahead of arrow upper value. So for A, B and C, ahead of the arrow upper value, that is 0. Ahead of the arrow upper value, that is 0. So 0, 0, 0. Let us write it down in the table. So here in the EST column, I have written down 0, 0, 0 for A, B and C. Now let us come back to the question and let's talk about D. Alright, so as you can see in the network, again for activity D, check activity D. Activity D, ahead of arrow upper value, that is 6. For E, again ahead of the arrow upper value, that is 6. So that is how we need to find EST, earliest start time. So let us complete the values in the table. Alright, so here is the column of EST, earliest start time. Entire table I have completed. Now EFT, earliest finish time. So that is the formula, EST plus duration. So duration plus EST. So 0 plus 6, 6, 0 plus 7, 7, 8 plus 0, 8, 6 plus 7, 13, 8 plus 6, 14, etc. So that is how we need to complete the EFT. So that is the column of EFT. I hope we are clear up to this point. Now LST and LFT. So first we need to find LFT. Let us come back to the network. Alright, so as you can see in the network, LFT is the end of the arrow below value. So for A arrow is ending and that below value. So that is 13, end of the arrow below value 13. For B, end of the arrow below value 7. For C, end of the arrow below value 11. So that is how we need to find LFT. So let us represent that. Alright, so that is 13, 7, 11 for A, B, C. Now let us again come back to the network. Now let us see for activity D, end of the arrow below value, that is 20. For activity E, end of the arrow below value 31. So that is how we need to finish the column of LFT. Let us see that. So here is the entire column of LFT. Now LST. So what is LST? LST is total duration. LST is LFT minus duration. LFT minus duration, that is your LST. So let us do that. Alright, so here is the column of LST. When you deduct the duration from the LFT, when you deduct the duration from the LFT, you will get LST. So now we have got EST, EFT, LST, LFT. So we can find the total float, either subtraction of finish time, either subtraction of start time. So LFT minus EFT or LST minus EST. So let us do LFT minus EFT. For A, LFT is 13, EFT is 6. So 13 minus 6, 7. For B, LFT is 7, EFT is 7. So 7 minus 7, 0. For C, LFT is 11, EFT is 8. So 11 minus 8, 3. So that is how we need to complete the entire table of total float. Let us complete that. So here is the entire table of total float, and now those activities who are having total float 0 considered as critical activity. So I have to write down critical in the column of remarks. Let us do that. So those activities who are having critical, those who are having total float 0, I have written down as critical. So now we need to represent these critical activities into network. So what are the critical activities? BFHIKL. BFHIKL. Let us represent that. So here, as you can see in the network, I have darkened BFHIKL. So that is my critical path, and I have written down the critical path as BFHIKL. See, students, critical path is a path on which all the activities, that is a path, so that will be start from end. These activities are must completed on time. If not, it will affect the total project duration. Alright, so that is my up to total float critical path. So I got the second answer. What is the critical path? Now remaining is the table of floats. So first is free float, interfering and independent. Let us see again. So now as you can see, again we are come back to the table. Free float, I need to find the free float. I've written free float for activity A is 0. How? Let us check. Let us come back to the network. So concept of free float is who is coming out from which activity. So first we are talking about activity A. So for activity A, D and E are coming out. For activity A, D and E are coming out. So we need to check EST of D and E. We need to check EST of D and E, and that value to be subtracted from EFT of A. Let us come back to the table. So EST of D and E are 6. So I can take any value. So both values are same. So 6. EFT of A, 6. So 6 minus 6, 0. Now let us see for B. So for B, as you can see in the network, from B, F and G are coming out. F and G are coming out. So let us see the EST of them. So for EST of F and G, EST of F and G are 7. EFT of B is 7. So 7 minus 7, 0. Now that is how you need to complete the entire free float table. Let us see for activity C. So for activity C, as you can see in the network, H is coming out. Now from the table, let us look at the EST of H. So EST of H is 11. EFT of H is 8. So 11 minus 8 will get 3. For again, now let us see for D, A, B, C. Now we have to see for the D. Let us come back to the network. So as you can see in the network, from activity D, I and J are coming out. Successor activities I and J. Now let us look at the EST of I and J. So here are the EST of I and J. So I and J, that is 20, both are same. EFT of D, 13. So 20 minus 13, 7. So this is how we need to complete the table of free float. Now in the case of activity L, let us see in the case of activity L. So in the network, as you can see, L is the last activity from which there is nothing coming out. So L will be the last activity. In such cases, EST will be taken as total duration, that is 40. Now EFT of L. Let us come back to the question. Let us come back to the table. So in the table, EFT of L is 40. So 40 minus 40, 0. So that is how we can find free float. I hope we are clear up to this point. Now interfering float is total float minus free float. So for A, 7 minus 0, 7 minus 0, 7. Apart from that, all the interfering float are 0. Total float minus free float. So that is your interfering float. Now independent float. So formula for independent float was TEJ minus TLI bracket minus duration. So let us see in the network. So in the network, as you can see, for activity A, end of the arrow above value, start of the arrow below value, that is 6 and 0. So 6 minus 0, 6 minus duration, again 6, so that will be 0. That is your independent float. Now B, end of the arrow above value, that is 8. Pardon me, for B, that is 7. Below value, ahead of the arrow, below value 0, 7 minus 0 minus duration, again 0. So that is how you have to find the independent float. End of the arrow ahead value, start of the arrow below value, subtraction, and that value should be deducted from the duration of the activity. So let us see the column of independent float. So that is how we have found out the independent float. So that is our sum number 2 of CPM method. Let us see another numerical, but this time involving dummy activity. So let us see the question. So here is another question that from the data given, prepare the table, find the total duration of the project and critical path of the network. So we have to find only two questions, total project duration and critical path. But first we need to prepare the table. So here predecessor and successor data are given with the activity duration, activity name, activity duration, predecessor and successor column are given. So I'm preparing the entire table with the use of successor data. So for A, successor is B and C. That means B and C follows A. Let us draw that. So here is the first activity A, and B and C is the following activity. So B and C follows A, or A is the predecessor of B and C. So that is my first network representation. Let's come back to the question again. Now from activity B, successor is DE, and activity C is successor is E. That means activity E is coming out from B and C. But again, let us come back to the last point of the network. So in the network, as you can see, we cannot merge the endpoints of B and C, because that is a grammatical error, because their start point is same, so we cannot have the endpoints same. So we need to have the dummy. Let us represent that. So as you can see, I have represented a dummy from B to C, and now I have represented D and E. So that is my D and E. Let us come back to the question. E has the successor of FG. So again, we cannot represent that by directly because F cannot be successor of both. So we need to represent the dummy. So let us draw that. So that is how we need to represent the dummy from E to above that side, and then we can have F and G. This drawing numerical we have done in the drawing of the network sum. So you can see that video, okay, that how to draw the network using dummy. Now let us number the event. So here is the final event event number 1 to 7, having activity name and duration, and dummy activities are having duration 0. You can have the name of dummy activity as D1 and D2, or you don't have to require the name the dummy activity, because dummy activity are those activities which are represented directly into the network to maintain the logic of the network. So we have to only represent them. We are not going to have any representation of dummy in our table calculation. So now the network is being drawn. We can start our forward and backward path analysis. So let us see the forward and backward path analysis. So as you can see, starting from point 0, now 1 to 2. So 0 plus 30, 30, 0 plus 30, 30. Let us represent it. So here is 0 plus 30, 30. Now 2 to 3, 30 plus 20, 50. Now for event number 4, there are two ways, 2 to 4 and dummy 3 to 4. So if I go from 2 to 4, 30 plus 30, 60. If I go from dummy way, 50 plus 0, 50. So 50 or 60, but we will consider maximum. So 60. Now 4 to 5. So 60 plus 60, 120. Now for event number 6, we have two options. 2 to 6 and 5 to 6. So if I go from 2 to 6, 50 plus 60, 110, 120 plus 0, 120. So 110, 120. So maximum is 120. And for last event, there are two options, 120 plus 50 and 120 plus 60. Sorry, 120 plus 50 and 120 plus 40. So 120 plus 50, 117, that is 160. So 170. And now I have done backward calculation, that is reverse path. So starting from last point 170. Now coming back from 7 to 6, that is only one way, 170 minus 50, 120. Now for point 5, there are two ways, 5 to 6. So and there are two outgoing arrows, 5 to 6 and 5 to 7. So two reverse paths, 7 to 5, 6 to 5. So if I go from 7 to 5, 120 minus 40, 130, 120 minus 0, 120. So 120 and 130. Minimum is 120. So I'll consider 120. Now for event 4, that is only one path, 5 to 4, 120 minus 60. So I'll get 60. Now for event 3, there are two ways, 4 to 3, 6 to 3. So if I go from 6 to 3, 120 minus 50, 70, 60 minus 0, 60. So 60 or 70, minimum is 60. Now for event 2, 70 minus 30, 40, 60 minus 30, 30. So 40 or 30, 30, and now 30 minus 30, 0. So that is how forward and backward has been calculated. So we got a total duration of the project, that is 170 days. Now to find the critical path, let us prepare the table. So here are the table to find the critical path: activity, duration, EST, EFT, LST, LFT, total float and remarks. Now first we need to focus on EST. EST is the ahead of the arrow upper value. Let us come back to the network. So for activity A, ahead of the arrow upper value 0. For B, ahead of the arrow upper value 30. For C, ahead of the arrow upper value 30. So that is how we need to create the table of EST, column of EST. Let us see that. So here is the entire column of EST. Now EFT, EST plus duration. So let us see that. So that is the column of EFT equals to EST plus duration. Now LFT. Let us again come back to the network. So here in the network, LFT, end of the arrow below value. So for A, that is 30. For B, that is 70. For C, that is 60. Pardon me, for both of them are 60. So 30, 60, 60. So that is how we need to find EFT. Let us LFT. Let us complete the column of LFT. So here is the entire column of LFT. Now LST. So LST is LFT minus duration. So LFT minus duration. Let us do that. So that is the column of LST. Now total float, LFT minus EFT, or LST minus EST. So I'm going with the start time. So deduct the start time of both of them. So we'll get the total float as following. So here is the column of total float, and those activities who are having total float 0, there can be termed as critical path. So activity ACEF is the critical. Let us highlight that into the network. So in the network, as you can see, ACE. Now F is on that side. So we need to highlight the dummy as the critical. So ACEF. So dummy can be your part of critical path. Students, that is true that dummy can be a part of critical path because path is a connected path. So I cannot highlight ACE. Now I don't highlight dummy, and now I highlight F. So there is not connecting path. So to connect the path, I need to highlight the dummy as critical. So ACE, dummy D2 and F. So ACE, F. So that is my critical path. You can try free float, independent float and interfering float by yourself. Here are the values of free float, interfering float and independent float. So here are the values of free float, independent float and interfering float. You can try by yourself. So this is it. That was all about in today's session. In case of any query or doubt, you can always contact me on my mail or my number. Thank you.